Yes. Okay. So so I guess, yeah. One of the interesting things that we observe in the Upper Cretaceous to the Neogene, or like in the Companion, is the regional compression and inversion. And so I guess that is clearly illustrated by this seismic line, where we can see compressional structures, and they occur across the Northwest Shelf. And so this is an example from the Baku subbasin. And yeah, as you can see, the structure is here. But one of the interesting things is that we also see anticlines of various ages and various orientations forming throughout the entire Cenozoic. So I guess this is also an example of the of this Cape Range anticline, or like, sorry, the structure map of the Aptian. And then, sorry, and then as you can see, this is the Cape Ridge anticline, a photo of the outcrop. And then you can see I guess these are carbonate platforms that are now, you know, uplifted. So, I mean, it is not clear if this is continued structural growth, or if it is a combination of superimposed dynamic topography and the structural component. So then in the Paleogene, so specifically in the Eocene, we have an onset of rapid migration of Australia from 50 MA onwards. And in the Oligocene, we have the initiation of a rift system as large as the Great Barrier Reef. So that work was carried out by one of Steve Gallagher's PhD student, Jackson McCaffrey, and they use extensive seismic lines throughout the Northwest Shelf. And then they were able to map this rift system. So in both in time and space. And that work was published in Global and Planetary Change last year. So then in the Miocene, that rift system, I guess, evolves through time, but then it declines after 10 million years. So to illustrate that, I have this cartoon here on the right that shows the temporal and spatial variability of that rift system. So, and that, I guess, rift system dies off, and to the point that now we just have isolated atolls and pinnacle rifts in the present. But then also, as Australia moves northward, and there are changes in circulation patterns, and then also more arid conditions in Australia from 16 to 6 MA. And then from 6 MA onwards, we have fluctuations between monsoonal and arid conditions. And then the other aspect that is really interesting about the Northwest Shelf is that then we have anomalous subsidence from 6 MA, and then anomalous uplift from 2 to 1 MA. And that work was carried out by Mike Gernys and Stephen Gallagher based on a bunch of IODP, or like one IODP expedition and multiple sites, IODP sites around this part of Australia. And what is interesting is that the nature, so the timing and the rate and the amplitude of that subsidence and uplift is the same. So they explore a range of mechanisms to interpret those observations, but they were not able to find a suitable explanation. So then, therefore, they conclude that a new geodynamic or tectonic model is needed to understand those ups and downs that the Northwest Shelf has experienced in the last 6 million years. So this is a seabed structure map that Chris and his army of students have created. And as you can see here, is the Exmouth Arch is a very clear feature that you can see. And then this inset is showing the a 3D perspective of a mass transport complex, which are like occur during the, or are present, or are easy to observe in this seabed structure map. So I guess this also shows how these mass transport complexes are present and how, I guess, relate to the collapse of the shelf margin. Okay, so just to summarize I guess, all these syntheses that we have presented, we have the opening of the Canning Basin in the Devonian, which was triggered by far-field stresses, which in turn caused lithospheric stretching. Then in the Carboniferous and the Permian, we have northeast, southwest oriented rift structures that control the overall geometry of the margin. And we have this diachronicity in the rifting. Then in the Triassic, we have these large-scale drainage systems with headwaters in Antarctica, Southwest and Central Australia, plus local volcanic sources. I guess Chris and I hypothesize sorry, I think that someone has their microphone on.
Yeah, I think it's Liam needs to turn his microphone off.
Yeah. And we hypothesized that the fail arm of the rift system plus the flexural substance of this large sediment pile might account for some of the large subsidence in a post-rift setting. And then we also have, then in the, I guess, second scene rift, we have a strong lower cross that helps explain the marginal rifting that we observed in the Northern Shelf and the distributed deformation that we observed in the Northern Canadian Basin. And then what is interesting is that then in the after 50 MA, we have the development of rift systems as large as the Great Barrier Reef, but then they die off as climatic and subsidence patterns change through time. And we have this anomalous subsidence and uplift that that we don't fully understand, I guess, what's the mechanism that's causing it. But again, it kind of like defies this idea that passive margins are passive, right? Yeah, so thank you very much for your time, and I'm happy to answer any questions.